Hi students, now in this video lecture we will start chapter solutions, which is a part of physical chemistry, right? And first of all, we'll define solutions. We are already aware of solutions, what is solutions and types of solutions. So solution is a homogeneous mixture of two or more components whose composition can be varied within certain limits. Let's quickly take an example and understand all these points. Right, so since let's take an example of a simple solution, which is solution of sodium chloride in water. Right, we add sodium chloride to it, right? So this is an example of liquid solution, right? So when you add sodium chloride to water, it will form a solution, right? And once it forms a solution, if you taste this solution from the top, it will taste salty, right? And if you taste it from middle, then from the bottom, it will taste same, right? So this is what means it's a homogeneous mixture, right? Homogeneous mixture is something that has its properties same throughout, right? So the properties of this solution is same throughout. From wherever you taste it, it will taste similar. So this is a homogeneous mixture, right? And now since this is made up of two components, right, sodium chloride and water, it's a binary solution. Binary, bi means two, it's a binary solution. Similarly, if we add sugar to it, it's a solution made up of three components, so it's a ternary solution. Similarly, if we add a fourth component, it will form a quaternary solution, right? So depending on the number of components, right, a solution is binary, ternary, quaternary, right? So now let's see what is a solvent and what is a solute. So solvent is here in this example. In this example, we know that water is a solvent and sodium chloride is a solute, right? And the physical state of this solution is liquid. So just remember three things, or just remember that the physical state of this solution and what is your solvent, right? What is the physical state of solvent and what is your solute? Here, physical state of this solution is liquid, right? So this is a liquid solution. Since the physical state of the solution is liquid, so this is a liquid solution, and the solvent is a liquid and solute is a solid. So this is a solution of a solid in liquid, right? So whatever solution you take a gaseous solution, liquid solution or a solid solution, whatever is the physical state of solution, solid, liquid or gas, the same physical state would be that of the solvent, right? And since in this solution, which is in larger quantity, water, and sodium chloride is in lesser quantity, we know that even if we commonly make a solution of sodium chloride or sugar in water, we add less water, we take less sugar or salt and more water, right? So in solution, whatever component is in larger quantity is a solvent and the other component which is in lesser quantity is a solute, right? So there are two ways to recognize solvent. First, check the physical state of the solution. Whatever is the physical state of the solution, then same would be the physical state of the solvent, right? And the second thing is, just see which of the two components in solution, or maybe more components, whichever component is in larger quantity, right, that would be solvent. So solvent would always be in larger quantity and would maintain the same physical state as that of solution, right? So solvent, two things about solvent. First is always in larger quantity, or always be in larger quantity, and second, it would be in the same physical state as solution, right? So we will understand this point as we go through the other types of solutions. Now we will talk about particle size. It's a true solution. So for all true solutions, the particle size would be up to 10 to the power of minus 9 meter or 10 angstrom. And if the particle size is bigger than this, bigger than 10 to the power of minus 9 meter, it would be counted under colloidal solution, right? And if the particle range for colloidal solution is 10 to the power of minus 9 to 10 to the power of minus 6 or 10 angstrom to 10,000 angstrom. If the particle size is in this range, it would be a colloidal solution. And if the particle size is greater than the particle size of colloidal solution, it would be a suspension, right? So we will talk about colloidal solution and suspension in a different chapter. We would not discuss it here over here. It would be under your you have colloidal a chapter, so colloidal solution in surface chemistry, right? So this is the particle size. Since the particle size of true solution is the smallest, it's very small, so the components of true solution like sodium chloride and water, it cannot be separated by simple filtration, simple physical methods like filtration. We know that we cannot separate salt and water in sodium chloride solution using filtration, right? Or settling down. Settling down is a process where you just keep your solution for some time and the solute or the solid will settle down. It won't happen in that, it won't happen in this case because of the smaller size of particles. So because of the smaller size of the particles of true solution, it cannot be separated by physical methods like filtration, settling or centrifugation, right? So component that has same physical state as solution is solvent and is present in larger quantity, right? We have discussed it over here. And the other one is which is present in smaller concentration is a solute. Now we have types of solutions. Types of solutions. Solutions can be a solid solution, a liquid solution and a gaseous solution. A solid solution would be, let's first take an example of liquid solutions, which we have already done. Liquid solution is where the physical state of the solution would be liquid, right? And since the physical state of the solution is liquid, so solvent would also be liquid and would be in larger quantity, right? Now let's take an example of liquid solutions. Salt in water, we have already done this. Soft drinks, right? Soft drinks, it's a very common example. We know that when we open soft drink, the gas comes out of it under a very high pressure, right? With a very high gush, it comes out of the bottle, right? Why? Because carbon dioxide is dissolved in liquid under high pressure, right? So here in this liquid solution, since we know that soft drink is liquid, right? So solvent would be liquid, right? And we have gas dissolved in it. So gas is in lesser quantity, it's a solute. So carbon dioxide in liquid is soft drink, right? Is a liquid solution in which solute is carbon dioxide, which is a gas, right? So solute, just don't get confused with simple solutions that we have studied before, that salt is always a solute. No, whichever is in lesser quantity is a solute. Like CO2 is now, it's a gas, so it's a solute, and liquid is a solvent, so it's a liquid solution. Similarly, if we take example of dissolved carbon dioxide, okay, ethanol in water. Ethanol is in water is again a liquid solution, right? Wherein water is in larger quantity, so is a solvent. Ethanol is in lesser quantity, is a solute. And here it's a both. Here solute is a liquid, ethanol is in lesser quantity, so it's a solute. So whichever is in lesser quantity is a solute. Now if we talk about gaseous solutions are, the physical state would be gas, right? So solvent would be again a gas, right? So it may contain a solid, liquid, or a gas. The solute, okay, solute can always be a solid, liquid, or a gas, right? Now let's take example of gaseous solutions. We know that since it's a gaseous solution, so solvent would always be a gas, right? So iodine vapors in air. Air is in larger quantity, air is solvent, and iodine vapor, we know that iodine is solid which sublimes on heating. So it enters into air when it sublimes. Sublimes means it changes from solid state to gas directly. So iodine in air is a solid solution, is a gaseous solution of solute, which is a solid iodine in air, which is gas. So it's a gaseous solution. And humidity in air, we know that humidity is water vapor, which is a liquid, right? In air, humidity in air is a gaseous solution. So the solvent would be a gas. It's air here, right? Since it's humidity in air, we know that air is in larger quantity. So physical state of air is gas, right? So it's a gaseous solution, and larger quantity, air is in larger quantity, so is a solvent, and humidity is in air. Humidity is in lesser quantity, which is water vapor, so humidity is a solute, right? So humidity in air is an example of gaseous solution in which solvent is air. Similarly, if we talk about solid solutions, in solid solutions the physical state is solid, so the solvent would be a solid. So alloys, we are already aware of alloys. So now we will see how solute can be a solid, liquid, and a gas. In this case, alloys, we know that alloy is, let's take an example of an alloy, steel. Steel is an alloy, right? Because when we mix carbon to iron, it forms steel. Here iron is in larger quantity and carbon is in lesser quantity. So iron is steel is a solid, right? Steel is a solid, so solvent would be iron, which is again a solid. So in solid solutions, solvent would always be a solid, right? So steel, which is a solid, right, solid solution. So we know that steel, since it's a solid solution, so solvent would be iron, which is in larger quantity, and carbon, which is in lesser quantity, is a solute, which is a solid solute. Now hydrated salts, we know that hydrated salt, for example copper sulfate, we have studied about this, copper sulfate .5H2O, this is a solid solution. Since it's a solid solution, so solvent would be, since it's a solid solution, so solvent would always be solid, and solute is here, this is a hydrated salt, copper sulfate pentahydrate. This copper sulfate contains, it's a hydrous salt. Hydrous salts are those that contains water molecules in its crystal lattice, right? So this, and we know that this water molecules that are associated with this salt is called water of crystallization. So this is, we know that copper sulfate pentahydrate is solid, right? So this is we take this as an example of solid solution, right? So this is a solid, right? So solvent would be a solid, which is copper sulfate, right? And what would be the solute? Solute would be one which is in lesser quantity. Water is in lesser quantity in copper sulfate, so here water is a solute, right? So I hope all this is clear to you. This is in lesser quantity, this is a solute, this is in larger quantity, so this is a solvent, and the physical state would be same as that of solvent, which is a solid. So physical state of this copper sulfate is solid, right? Same physical state as solution, solvent, and is in larger quantity, which is again a solid. Hydrogen absorbed. Hydrogen, since if it's a metal, we know that hydrogen gas gets absorbed on this platinum metal, which is a solid. Hydrogen gas absorbed on platinum metal is an example of solid solution, in which this solid is a solid solution, so solvent would be solid, which is platinum. This would be solvent here, and since it's a solid solution, solvent would be solid, which is platinum, and the one that is in the lesser quantity, which is hydrogen is a solute. This is in lesser quantity. First thing is in lesser quantity, as in it's in a different physical state compared to this solid solution. So this is a solute. So solute would be in a different physical state compared to the physical state of the solution, and is in lesser quantity, right? So like we have two things for solvent. So for solute also we have two things. First is lesser quantity is present in lesser quantity in solution. Second point would be it's in different physical state. Compared to solution, right? Now we have liquid solutions, right? This is clear now. We have liquid solutions. Liquid solution is wherein both the solute and solvents are liquid, right? Let me quickly run this. For example, wherein both the solute and solvent is in liquid state is ethanol in water, benzene in water, right? Phenol in water. All these are liquids, right? So let's see how these are different. Liquid solutions are of three kinds. Miscible, we have heard of these terms before. Miscible liquid solutions. In this, the nature of both the liquids is same, right? For example, both the liquids would be polar. If both the liquids are polar, it would form a miscible solution, right? Like ethanol in water, both are polar, so it will form miscible. These ethanol in water, we know that ethanol in water completely mixes. If you add ethanol to water, it completely mixes, right, and form a homogeneous mixture. So ethanol in water is an example of a miscible liquid solution, right? And why it forms up miscible liquid solutions? There is a condition for a miscible liquids, for miscible solutions, that both the components, that is both the liquids, should be of similar nature. That is, both the liquids should be either polar or non-polar. Ethanol and water both are polar, so it forms a miscible solution. We have something called as immiscible. Since these are of similar nature, that is, similar nature means both liquid